Hi. So we are going to discuss about basic concepts of Kafka, like what exactly is a topic, right? What is a partition, right? We hear them a lot. So we will produce to a topic and a consumer reads from a topic and topics are partitions and they are divided, right? We hear a lot. So now we are going to discuss about each of them. Firstly, topics. So what is a topic? So topic is a unique category or a name that is given, right? It's like a file storage where it stores different types of files. So you have different folders, right? So folder A, folder B, similarly, topic A, topic B, you can name it, but these should be unique given in a Kafka cluster, right? It's useful in organizing the data. So if I want some particular data to reach a consumer, so I will just put that data to a particular topic. Let's say topic A, and I have another topic B where I need some additional data or which is not required by another consumer. So I will produce it to topic B, right? So this is how topics are helpful in organization, right? And we have numerous configuration to control the behavior of a topic, right? So how long a message in a topic should stay, right? Retention.ms, we have this property where we can define how many milliseconds we want that message to reside in the topic. We have multiple consumers that can subscribe to a topic. This is how parallelism is achieved in Kafka, right? A single consumer can subscribe to multiple topics, or multiple consumers can subscribe to a single topic, right? Next, we have partitions. What are partitions? So each topic is divided into several partitions, right? So they are essentially ordered and are immutable sequence of messages, right? So it allows parallelism in processing data. Let's say partitions. I have 10 partitions to a topic. So what happens is when we put a message, this message can reach to any of the partition, right? So when a consumer picks up or a consumer group, we are going to discuss what it is. So there are multiple consumers in a consumer group, and each consumer will be assigned a partition, and no consumer in a consumer group will have same partitions. So this is how parallelism is achieved, right? Each partition is replicated across multiple brokers. We have discussed about brokers, right? So what brokers are? These are nothing but servers where Kafka servers are running in, right? So each partition is replicated across multiple brokers based on a replication factor. So when we create a topic, we provide a replication factor, right? So replication factor cannot be more than the number of brokers we have. When we produce a message to a partition, order is maintained within a partition, not across the partitions, right? This is how partitions are used. And also partitions enable horizontal scalability, right? Because the data is distributed across multiple brokers. So Kafka will be able to handle large amounts of data and it can provide high throughput as well, right? So next we have producers. Producers are nothing but the client applications that publishes message to Kafka topics. If you remember the location example we have taken, we produce the messages to a topic, right? Producer is responsible for generating data and sending it to Kafka brokers. And also, producers create these records and send them to brokers, right? So while sending this data, we can append a key, right? Where every key, if you provide, let's say a message is produced with a particular key, key A. So all these key A related messages will go into a particular partition, right? So this is how ordering is achieved if order is critical in processing the messages, right? And also error handling. Since these are client applications, these can handle errors based on, we have several exceptions that can occur due to network errors or broker is not responding or there are no enough replicas, right? And also there is several properties of producers based on which retries can be decided. And also we have asynchronous and synchronous mode of publishing. So we need not to wait till the message is published. We can just put it asynchronously and we can get an acknowledgement later. And next, what we have is consumers. So consumers consumes messages from a topic, and as we have discussed, it can subscribe to multiple topics. So consumers are always part of consumer groups. So these consumer groups contain one or more consumers. So within a consumer group, each partition of a topic is assigned to only one consumer. So what this does is it ensures that each message is consumed by only one consumer within the group, which allows for parallel processing of messages, right? And also offsets. Offsets are committed to consumer offsets topic, right? As you can see. So this consumer offsets topic has the latest offsets that is committed by a consumer. So when a consumer goes down, it can resume from where it has stopped, right? So yeah, that is how it's fault tolerant in a way. And rebalancing when a consumer dies or leaves the group, Kafka automatically handles consumer rebalancing when consumers join or leave a group. This ensures that partitions are evenly distributed among consumers within the group. So this is what about topics, partitions, producers, and consumers. There is more to what we have discussed, like producers have number of configurations and consumers and how these producers created using Java or any other language, and consumers, how these consumers are created, right? We are gonna do hands-on with them. So see you soon.